Hey everybody, this is Dr. Jacobs. Welcome to our lecture over understanding research results, description, and correlation. There are some unit learning objectives that I would like you to be able to do by the end of this unit. I'd like you to be able to compare and contrast the three ways of describing results. For example, comparing group percentages, correlating scores, and comparing group means. I want you to be able to describe a frequency distribution, including the various ways to display a frequency distribution. I'd like you to be able to compare and contrast three measures of central tendency. I'd like you to be able to describe how to determine how much variability exists in a set of scores. I'd like you to be able to define what a correlation coefficient is. I'd like you to be able to explain what an effect size is. I'd also like you to be able to describe how researchers use regression equations to predict behavior. Distinguish between mediation and moderation as ways to explore more complex relationships among variables. Explain the purpose of more advanced statistical techniques like structural equational modeling. So to start off, we're going to do a little bit of a review of levels of measurement. This is something that should have been covered in detail in your statistics course, which was a prerequisite to this class, but sometimes different instructors leave out some of this information. In our materials, they called it scales of measurement, but we're going to avoid calling it that for now. Okay, so levels of measurement. We have a mnemonic that we can use to remember these different ones. There's going to be 4 that I teach you, and that mnemonic is NOIR. So each of those represent one of the levels of measurement from the most basic, starting at the end, to the most sophisticated that ends with the R. So the first level of measurement that we're going to learn about is nominal data. So this is whenever we have data, and the numbers represent categories rather than numerical values. Okay, so this could be, you probably filled out some sort of survey that said 1 equals male, 2 equals female, 3 equals intersex, 4 equals prefer not to respond. Well, I didn't have to actually put those categories in that order because the one's not meaning anything numerical. It's just trying to say 1 equals this category. In fact, I could have said 1 equals prefer not to respond, 2 equals female, 3 equals intersex, 4 equals male. It didn't matter. And that's because these numbers are just simply representing categories. Then the next level of data or level of measurement is ordinal data. And this is when numbers have an order, but lacks equal distance in between them. So in my statistics class, we often will go out and race outside to prove the point that if we just know who came in first, second, third, and fourth place, that's ordinal data. We know the order that they came in, but we don't know how much time elapsed in between each of those runners based off of that data alone. So here the numbers have an order, but we don't know if the distance in between those numbers are equal or not. The next level of measurement is the one that's the most difficult to understand, and this is interval data. This is when numbers have an order. They also have equally distanced intervals, but the 0 for interval data is a placeholder. It doesn't actually mean the lack of some attribute. So if we're looking at shoe size, for example, and we have a shoe size 0, the 0 means that the shoe is that whatever size that size 0 shoe is. It doesn't mean that there's not a shoe there. So if it's interval data, you'd have 0 as kind of that placeholder, but then there would be the same amount of distance from a size 0 shoe to a size 1 shoe as there is a 1 to a 2, a 2 to a 3, a 3 to a 4, and a 4 to a 5. The next level of measurement is ratio level of measurement. This is where numbers have an order. We have equally spaced intervals, and the 0 is meaningful. In other words, the 0 means none or lack of. So my favorite example, if you were in my stats class, you're probably knowing what I'm about to say, is if we have 0 street tacos, that means we've had no street tacos and we are sad. Okay. Sometimes this one messes people up just a little bit because they're like, well, I can't weigh 0 pounds. So like, what level of measurement is pounds? I can't weigh 0 pounds. That's not possible. Yeah, but the 0 means the lack of the attribute. So weight is on a ratio level of measurement. And so the reason why we want to call these levels of measurement and not scales of measurement is when we hear the term scale, it typically indicates that the data falls on an interval or ratio level of measurement. So if we are putting our data sets into SPSS, which is a data statistical software, you can identify the level of measurement that your dependent variable is. You can say it's nominal, ordinal, or a scale. Okay, and so instead of we'll call these levels of measurement and then reserve the term scale to indicate that the data falls on an interval or ratio level of measurement. This is something that I want you to know. And this becomes important because a lot of times the statistical analyses that you learned in your stats class prior to this, most of the dependent variables need to be on a scale in order to conduct those parametric analyses that you learned about. All right, so we also have frequency distributions. If you're in my stats class, you're also probably crying right now because you hated that word distribution. But a distribution is how frequently each value is selected within a data set. Okay, so there's several different ways that we can visualize these distributions, including pie charts, bar graphs, frequency polygons, histograms, and frequency distribution tables. So even if we don't display our distribution visually through one of those methods, a data set always has some sort of underlying distribution. So statistics, a little bit of review in that, because this is what our materials for this week does. Statistics can be broken down into two major branches. We have descriptive statistics and inferential statistics. We have descriptive statistics when we describe our data in one or a few numbers, and there's several different ways that we can do that. And then inferential statistics is when we use a sample to make guesses about what's going on in an overall population. Okay, so descriptive statistics, we have three major branches. The materials only covered two of those branches. We have measures of central tendency. This is where we describe the center of a data set in one or a few numbers. So for example, the mean, median, or mode. Measures of variability describe how spread out a data set is in one or a few numbers. For example, range, mean absolute deviation, variance, or standard deviation. Measures of distribution, this is the branch that was left out of our book for this week. These are these describe the shape of a distribution in one or a few numbers. So two primary examples of that would be skewness and kurtosis. So for measures of central tendency, the mean is symbolized by capital italicized M or X bar. Unfortunately, with Google Slides, it wasn't allowing me to get an X bar in here. And this is when we add up all the data provided by our participants and then divide that sum by the number of participants or sample size. In order to calculate the mean, your data set must fall in an interval or ratio level of measurement and be free of outliers. So in other words, your data must be on a scale. Then we have median, which is symbolized by capital M, lowercase d, lowercase n. And the median is the very middle of the data set when you line the data set up from the smallest to largest values. So if you have an odd number of participants, it's the very middle. If you have an even number of participants in your data set, then it would be the average of your two middle data points. So data must fall in an ordinal, interval, or ratio level of measurement in order to do the median. It doesn't matter if there's an outlier to do the median because the outliers will go on the outside when we're ordering our data from the smallest to largest, which is often why we find that when they report annual household income, that they'll report it as a median and not a mean. Then we have mode, symbolized by capital M, lowercase o. And this is just the most frequent value or values in a data set. And that can be used for data on any level of measurement. So measures of variability, range then is just the difference between the largest and smallest values of a data set. We know that if you took stats with me, there's two different types of range. So this is just the basic definition that most people know. Then this one was not included in our book. Our book provided the wrong definition for standard deviation. If you had stats with me, you know why. But what the book defined as standard deviation is actually something called the mean absolute deviation, which is symbolized by capital M, capital A, capital D. And this is the average distance the X values in a data set are away from the mean. Because they got the definition for standard deviation wrong, they also got the definition for variance wrong. The symbol for variance is S squared if we're talking about the variance of a sample, or it is lowercase sigma squared if we're talking about the variance of a population. And the definition of this is just the average of the squared deviation scores. Then the standard deviation, which has three different symbols. We could have lowercase s, which is standard deviation of a sample, lowercase sigma, which is the standard deviation of a population, or capital SD, which represents a standard deviation of a sample or a population. And this is just the square root of the average squared deviation scores. So in other words, the standard deviation is just the square root of the variance. So then we have our measures of distribution. Skew tells us how lopsided or symmetrical our distribution is. And kurtosis tells how peaked or flat our distribution is in comparison to the normal curve. So although the book said that we were only going to study descriptive statistics, it actually moved into some of the inferential statistics, and it should move into more of them for next time too. Some different inferential statistics you might have learned before include the one sample z-test, the independent samples t-test, the dependent samples t-test, the ANOVA, Pearson product moment correlation, which is something I went over this week, linear regression, and the chi-square statistic. Those are probably ones that you learned in your prereq stats class. So one of those, the Pearson product moment correlation, the book started to go over. Here we'll see a scatter plot as an example. And basically a Pearson product moment correlation, sometimes called Pearson's R, just tells us how strongly two variables that are on a scale relate to one another. So we have two variables, both of them have to either be on an interval or ratio level of measurement. And this number just tells us how strongly they're related. Pearson's R ranges from a -1 to a +1, where 0 means there's absolutely no relationship. A +1 indicates there's a perfect direct relationship, while a -1 indicates a perfect indirect relationship. So we can create a scatter plot like we find here on this slide, kind of visualize the relationship between the two variables. You'll find that there's a line in this little illustration that shows what a perfect correlation would look like. And then we see how the relationship between each of the variables in our data set are related. And it's a pretty good direct relationship here. Effect size, so a type of follow-up analysis that we could conduct if we find statistically significant results. In other words, we reject our null hypothesis. And we do effect size because whenever we're doing the hypothesis testing steps, whenever we find significant results, that just tells us that the results we got are likely not due to chance. And then so for Pearson's R, we can use an effect size to tell us how strong the relationship between the two variables is. So whenever we just do the decision whether to reject or retain our null hypothesis, that just tells us we have significant differences, not necessarily how big those relationships or how big those differences are. So the symbol for this, or R squared, tells us the amount of shared variance between the two variables. So if you go back to your understanding of variance and standard deviation from your stats class, that's what the R squared is telling us. And we'll use effect size for other inferential statistics as well, which we can talk about later. Regression, then, this is a type of inferential statistic that we use to make predictions. We create a regression equation off of a data set and determine if that equation makes better predictions than chance. So simple linear regression, which might be analysis that you learned in your statistics course, uses one predictor variable to make predictions about one outcome variable. Our materials are our reading for this week called that a criterion variable. More frequently, we're going to hear outcome variable when we're out in the real world. Multiple regression then uses multiple predictor variables to make predictions about one outcome variable. The book also mentioned mediation. Mediation is something that's really difficult for people to understand. So hopefully this slide on mediation, the next one on moderation, will help kind of help with that understanding. You'll want to just memorize this information because it's something that will keep coming back for you. So mediator often explains, or a mediator explains the relationship between the independent and dependent variables. So an example is that a real life mediator is temperature on a stove. So a water will not boil until you turn on your stove. But when you turn on the stove knob, it's not actually that knob that's causing the water to boil. It's the heat that results from the turning of that knob. So when we're looking at mediation, turning on the stove knob does cause water to boil, but not directly. It is actually mediated by the heat. The heat is what causes the water to boil. So then moderation then is slightly different and a little bit more difficult for people to understand. Moderation is a quick way to check whether that a third variable influences the strength or direction of the relationship between an independent and dependent variable. So a real life example is, say there is a relationship between the amount of time someone studies for a calculus-based physics exam and their grade on that test. Well, one moderator might be the grade level, right? So if you are a senior in high school, yeah, time spent studying might cause you to get a better exam grade. However, if you are a kindergartner, that might not be as true. So as you turn that knob, that grade level knob, as the grade level increases, there might be an increasing strength in the relationship between the time spent studying and the exam scores. So then it starts talking about a little bit more advanced statistical techniques, including structural equation modeling, which is also called SEM. And we use this as a multivariate statistical analysis. That means super fancy to analyze different structural relationships. So basically, we use SEM to test different models, very complex theoretical models. And that's something that is super advanced. That is like a 6th stats class. So that's what we got for this week. Hopefully it helped jog some of your memory with some of the statistics things that you learned in the past. And I look forward to talking to y'all next time. Have a great week.